The future is coming, and sooner than you think. These emerging technologies will change the way we live, how we look after our bodies, and help us avert a climate disaster. Let's move forward. Number 10. Clothes that can hear. Wearable technology has come leaps and bounds over the years, adding new functionalities to the accessories and clothes we wear day to day. One promising avenue involves giving clothes ears, or at least the same capacity as an ear. Researchers at MIT have created a fabric that is able to detect a heartbeat, hand claps, or even very faint sounds. The team suggested that this could be used wearable tech for the blind, used in buildings to detect cracks or strains, or even woven into fishnets to detect the sound of fish. For now, the material used is thick and a work in progress, but they hope to roll it out for consumer use over the next few years. Number 9. Sweat-powered smart cloths. Engineers at the University of Glasgow have developed a new type of flexible supercapacitor, which stores energy, replacing the electrolytes found in conventional batteries with sweat. It can be fully charged with as little as 20 microliters of fluid and is robust enough to survive 4,000 cycles of the types of flexes and bends it might encounter in use. The device works by coating polyester cellulose cloth in a thin layer of a polymer, which acts as the supercapacitor's electrode. As the cloth absorbs its wearer's sweat, the positive and negative ions in the sweat interact with the polymer's surface, creating an electrochemical reaction which generates energy. Conventional batteries are cheaper and more plentiful than ever before, but they are often built using unsustainable materials which are harmful to the environment, says Professor Ravinder Daya, head of the Bendable Electronics and Sensing Technologies (BEST) group, based at the University of Glasgow's James Watt School of Engineering. That makes them challenging to dispose of safely and potentially harmful in wearable devices, where a broken battery could spill toxic fluids onto skin. What we've been able to do for the first time is show that human sweat provides a real opportunity to do away with those toxic materials entirely, with excellent charging and discharging performance. Number 8. Sand batteries. Not every technology bettering our future has to be complicated, some are simple, yet extremely effective. One of these kinds of technologies has come from some Finnish engineers who have found a way to turn sand into a giant battery. These engineers piled 100 tons of sand into a 4 by 7 meter steel container. All of this sand was then heated up using wind and solar energy. This heat can then be distributed by a local energy company to provide warmth to buildings in nearby areas. Energy can be stored this way for long periods of time. All of this occurs through a concept known as resistive heating. This is where a material is heated by the friction of electrical currents. Sand and any other non-superconductor are warmed by the electricity passing through them, generated heat that can be used for energy. Number 7. Realistic holographs. Holograms have been filling science fiction books, films, and culture for years now, and while it does exist, it remains a difficult thing to achieve, especially on a large scale. However, a potential technology that could change this is holobricks. Developed by researchers from the University of Cambridge and Disney Research, holobricks are a way of tiling together multiple holograms to produce a large, seamless 3D image. The issue with most holographs right now is the amount of data that they require to make, especially when done on a large scale. A regular HD display for a 2D image takes about 3 gigabytes per second to generate. A hologram of a similar size and resolution would be nearer to 3 terabytes per second, which is a huge amount of data. To combat this, holobricks would provide individual sections of one large holographic image, heavily reducing the amount of data needed. This could eventually lead to the use of holograms in daily consumer entertainment like movies, games, and digital displays. Number 6. Brain-reading robots. No longer a science fiction trope, the use of brain-reading technology has improved hugely in recent years. One of the most interesting and practical uses we've seen tested so far comes from researchers at the Swiss Federal Institute of Technology Lausanne, EPFL. Thanks to a machine learning algorithm, a robot arm, and a brain-computer interface, these researchers have managed to create a means for tetraplegic patients, those who can't move their upper or lower body, to interact with the world. In tests, the robot arm would perform simple tasks like moving around an obstacle. The algorithm would then interpret signals from the brain using an EEG cap and automatically determine when the arm had made a move that the brain considered incorrect, for example moving too close to the obstacle or going too fast. Over time, the algorithm can then adjust to the individual's preferences and brain signals. In the future, this could lead to wheelchairs controlled by the brain or assistance machines for tetraplegic patients. Number 5. 3D printed bones. 3D printing is an industry promising everything from cheap house building to affordable rugged armor, but one of the most interesting uses of the technology is the building of 3D printed bones. The company Ossiform specializes in medical 3D printing, creating patient-specific replacements of different bones from tricalcium phosphate, a material with similar properties to human bones. Using these 3D printed bones is surprisingly easy. A hospital can perform an MRI, which is then sent to Ossiform, who create a 3D model of the patient-specific implant that is needed. The surgeon accepts the design, and then once it is printed, it can be used in surgery. What is special about these 3D printed bones is that because of the use of tricalcium phosphate, the body will remodel the implants into vascularized bone. That means they will enable the full restoration of function that the bone it is replacing had. To achieve the best integration possible, the implants are of a porous structure and feature large pores and canals for cells to attach to and reform bone. Number 4. Self-healing living concrete. Scientists have developed what they call living concrete by using sand, gel, and bacteria. Researchers said this building material has structural load-bearing function, is capable of self-healing, and is more environmentally friendly than concrete, which is the second most consumed material on Earth after water. The team from the University of Colorado Boulder believe their work paves the way for future building structures that could heal their own cracks, suck up dangerous toxins from the air, or even glow on command. Number 3. Car batteries that charge in 10 minutes. Fast charging of electric vehicles is seen as key to their take-up, so motorists can stop at a service station and fully charge their car in the time it takes to get a coffee and use the toilet, taking no longer than a conventional break. But rapid charging of lithium-ion batteries can degrade the batteries, researchers at Penn State University in the US say. This is because the flow of lithium particles known as ions from one electrode to another to charge the unit and hold the energy ready for use does not happen smoothly with rapid charging at lower temperatures. However, they have now found that if the batteries could heat to 60 degrees Celsius for just 10 minutes and then rapidly cool again to ambient temperatures, lithium spikes would not form and heat damage would be avoided. Their study, published in the journal Joule, showed they could fully charge an electrical vehicle in 10 minutes. Number 2. Drowned forest fires in sound. Forest fires could one day be dealt with by drones that would direct loud noises at the trees below. Since sound is made up of pressure waves, it can be used to disrupt the air surrounding a fire, essentially cutting off the supply of oxygen to the fuel. At the right frequency, the fire simply dies out, as researchers at George Mason University in Virginia recently demonstrated with their sonic extinguisher. Apparently, bass frequencies work best. Number 1. Living robots. Tiny hybrid robots made using stem cells from frog embryos could one day be used to swim around human bodies to specific areas requiring medicine, or to gather microplastic in the oceans. These are novel living machines, said Joshua Bongard, a computer scientist and robotics expert at the University of Vermont, who co-developed the millimeter-wide bots, known as Xenobots. They're neither a traditional robot nor a known species of animal. It's a new class of artifact, a living, programmable organism.